Let's get set up for our journey with R. We need to gather together the equipment we're going to use, and surprise, surprise, the first item we need is R. The second item that we're going to use is RStudio. First, a brief introduction of R. There are only two kinds of languages: the ones people complain about and the ones nobody uses. So you have a license to complain about R while you are learning R, because if you weren't complaining about it, you're probably not using it. R is actually a descendant of the S programming language. S came before R. I know that sounds backwards. S was developed at Bell Laboratory under the director of John Chambers. Bell Laboratory actually was the scientific development center for Bell Telephone, which was a predecessor of AT&T. John Chambers says this about the S programming language, and it applies very much so to the R programming language. We wanted users to be able to begin in an interactive environment where they did not consciously think of themselves as programming. Then, as their needs became clearer and their sophistication increased, they should be able to slide gradually into programming when the language and system aspects would become more important. And that's in fact what happens with R. We learn some basic functions. We start then to use those functions in more sophisticated ways, and without even knowing it, you're actually programming. Even students who have taken my past statistics courses, when we never had any formal instruction in R, learn how to manipulate the objects within a script in order to obtain the results that they want, whether it's graphs or descriptive statistics and so on. So really, the S programming language, and then after that the R programming language, did achieve this goal that they were looking for. So a brief history of R. R is a dialect of S that uses semantics and logic from another program called Scheme. S was developed in 1976 by John Chambers and colleagues at Bell Labs, and Scheme was developed in the 1970s by Guy Steele and Gerald Sussman at the MIT Artificial Intelligence Lab, and is related to Lisp. When I was in graduate school, we used to work with Lisp as an artificial environment for educational innovations. S was rewritten in the C programming language in 1988 and resembles the current implementation, which evolved into S+ and became a purchase program developed by Insightful Corporation, sold as S+, and now owned by TIBCO. TIBCO released their version of R, which they call the TIBCO Enterprise Runtime for R, which is an alternative to the publicly and freely available R. Now, R itself was created in 1991 by Ross Iheka and Robert Gentleman from the Department of Statistics at the University of Auckland and announced to the public in 1993. It was announced to the public, but as you'll soon see, not released to the public until substantially later. But let's take a look at the two inventors of R, Ross Iheka and Robert Gentleman. Here they are. And where does the term R come from? They did it for two reasons. One, look at their first names, Ross and Robert. And two, because they were creating a dialect of S, they decided as homage to S that they would stick with the single letter, So R from their first names and a single letter to pay homage to S. In 1995, 2 years after this was announced to the public, Martin Makler convinced Ihega and Gentleman, the two R's, to license R with the GNU General Public License, which basically meant that it would become free software and open source software. And that was a crucial decision. So rather than creating a commercial product, they were convinced that they were going to provide this for free to anyone who wanted it, as well as the code behind everything that they had done. And that has been a significant decision that has led to the explosion of R and its popularity. The R core group, which still exists today, was formed in 1997 and releases updates to R. Ross and Robert are no longer solely responsible for releases of R, but they do sit on the R core group, as does John Chambers, who invented S. And this R core group is the core group that is responsible for the official versions of R that are released to the public. They release about 2 or 3 updates a year, and these updates are, as you will see, if you haven't already, always known by unique and interesting and sometimes humorous names. But the first release wasn't until 2000, and so we've now been with 20 years of R. R version 1.0.0 was released in 2000. At the time of this recording, the most recent release is R version 4.0.3 that was released this past October. And the name of that version is Bunny Wunnies Freak Out. So this is the version that you actually should install on your system if you've not done so already. If you have an older version of R installed on your system, I would recommend that you install the current Bunny Wunnies Freak Out version so that we are all starting at the same place. The official distribution of R and packages is on what is known as the CRAN. The CRAN stands for Comprehensive R Archival Network. And CRAN is the source not only of R, but of the thousands and thousands of packages that are available in R that can help extend R and do specifically what you want it to do. We will take a look at packages at a later date, but right now, note that CRAN is the official distribution site, and CRAN has what are called mirrors all over the world. That is, various places where you can go in order to download everything that is on this archival network. Now, the second piece of equipment that we want to take with us on our journey is RStudio, which, as you will see, makes it a whole lot easier to run R. The chief scientist at RStudio is Hadley Wickham, and here is what Hadley Wickham says about R's biggest challenge. It is that most R users are not programmers. I hope to help more R users become R programmers. What he's saying here is not that he wants more programmers to start using R, but rather he wants everyday people like you and I who are R users to become more proficient in R and be able to program it for our own needs. And that's what we're going to learn how to do in this class. We're going to learn how to become R programmers. I know that can sound really intimidating, but if you think that what a program is simply telling the computer to do something, what this means to become an R programmer is to make R do what we want it to do. And that is the huge advantage of R. That's why it's gained so much in popularity. You are restricted with any other statistical software to running what is built into that software. Now, in all fairness, even SAS and SPSS provide ways to access scripts, but mainly those scripts are for calling SAS or SPSS pre-created functions. That's typically what those do. We can do that in R, but we can also create our own functions in R. This is really why it has become so popular. The combination of it being open source and free, a decision, as we saw, made in 1995, and the fact that anyone who is an R user can gradually migrate to being an R programmer. And I would suggest you can start out being a novice programmer using the built-in functions more, and then gradually migrate to creating more of your own functions. So in the spirit of what John Chambers said, he wanted individuals to not even realize they're becoming programmers. In this course, you do realize it because you're signed up in this course to take a certain path. So you know that what you want to do is to be able to become better at not just using R, but making it do anything you want. Is it worth it? Well, here is a little diagram I found on the website Guru99. Within the context of data science, the bigger the circle, the more use. So you see we have two really big circles here. One is for Python and one is for R. Just slightly smaller than that is Excel. And then we have about halfway in between the smallest circle, which is MATLAB, and the R and Python circles, we see SAS. So you see that R and Python are the most used by data scientists. The vertical axis represents the learning curve. The higher up you are on that, the easier it is. So Excel is easy. But then on the horizontal axis, the further you go to the right, the bigger its capability rating. And so R sits there the furthest to the right, but it also is fairly low on this graph, meaning that it might take a little bit more time to learn. It's substantially more difficult to learn than, say, Excel. But it's worth it because it sits there with a score of 10, the highest score in terms of its capabilities, even though the learning curve rating is at 4, while Excel sits up there with the highest score, meaning the easiest to learn, as 10. RStudio is going to help us tremendously with our work in R. This is an integrated development environment for R, so really it is an overlay on R. R will run within RStudio. RStudio is free and open source, just like R is. It was founded by Jay Allaire in 2010, and the first version of it released just 5 years ago. So those of you who have had me for a statistics course and you know how we use RStudio, in a moment I'm going to look at R with you, and we're going to see what it would be like without RStudio, and you're going to be very glad that it's been around for these 5 years while you've been taking statistics. RStudio is available in commercial and server editions that cost, but we don't need to use those in this class. We're always going to stick with free. All versions of RStudio, as well as add-ins and packages that make it easier to work with R, are all available for download from the RStudio website.